Okay, so we're going to have a look today at some special indices examples. So this is examples of questions where we're going to involve quadratic equations. So these involve solving quadratic equations. So let's see how this situation arises. Now, first of all, to say in general, we can't solve equations such as this. 5 to the power of 2x plus 5 to the power of x plus 1 equals 5 to the power of 3. This isn't the same as the questions we did previously where we try and get a base 5 on each side and we let the powers equal each other. There's two terms on the left and they're separated with a plus, and we couldn't just say something like 2x plus x plus 1 equals 3. It doesn't work like that. For that situation to work, we have to have a single 5 on each side with a power above each 5. We can't have it when we have two separate terms that both have powers in them. So we're going to have to think of a different way to do a question like this. And how we do it is we are going to temporarily replace something in the equation with a different letter. And I'll show you what I mean after we write it out. So we have 3 to the power of 2x plus 1 minus 28 bracket 3 to the power of x plus 9 equals 0. And some people might look at this and think, you know what, this kind of resembles a quadratic. We have, you know, a term here, we can see the 2 here in the power, we have another term in the middle that obviously has x's in it, and then we have a term at the end that has no x's. And so some people might say it closely resembles a quadratic, even though it's not quite a quadratic yet. So I'm going to do something that isn't immediately obvious as to why I'm doing it, but it'll appear obvious then as we go through the question. So I'm going to temporarily replace any 3 to the power of x's with the variable y. Now the reason we use y is because we've already used x in the question. If we want to make a quadratic, it would be nice to have that quadratic have x's, but we've already have an x in the question, and so that would only make it more confusing. So we're just going to use y, but we could use any letter. Now this 3 to the power of x is going to be replaced with a y. But up front here, I need to rearrange this using the rules of indices so that I can isolate a 3 to the power of x, which I can then replace with y. So how am I going to do that? Well, we know that there's a rule that says a to the power of 7. So we know that there is a rule that says if you have a base number to a particular power, let's say 7, multiplied by another base number to that same. So we know that if we have a base number to a power, let's just pick 7, multiplied by the same base number to a different power, let's say 2, we know we can add those together and say 7 plus 2, which is 9. Well, likewise, if we have two things that are being added in the power, we can go backwards and separate. So we know that one of the rules of indices says that if we have a letter, So one of the rules of indices we know says that if we have a number a to a particular power, let's say 7, and then the same number is multiplied with a power, let's say 2, that we can join them and have that base number a to the power of 7 plus 2, which we know is going to be 9. But we can also work backwards and go the other way. If we have the sum of two things in a power, we can then split them again into their two separate bases. And that's what we're going to do with this up here with this 2x plus 1. We're going to say that that's 3 to the power of 2x times 3 to the power of 1. We're going to then also still have our minus 28, 3 to the power of x plus 9 equals 0. Now we're trying to get a 3 to the power of x in this first little bit, and we don't have that just yet. But I can replace the 3 to the power of 2x with 3 to the power of x squared. So again, if we had a to the power of 7 squared, we know that we can say that that's a to the power of 7 times 2, which is 14. But equally, we can work the other way. If we have two things multiplied by each other, like we have here 2 by x, we can split them like this again. Okay, that's going to be multiplied by the 3. Sometimes we see a little dot for the multiplication. Then we have the minus 28 bracket 3x plus 9 equals 0. And now we can see we have this 3 to the power of x. And so what I'm going to do is I'm going to replace the 3 to the power of x's with y's. Just temporarily, I'll put them back near the end of the sum, but I'm just changing them so that we can create a quadratic. So this is y squared, and then the 3 there is obviously as well. So this is 3y squared. Okay, so y squared and then times the 3 minus 28 times y plus the 9 is equal to 0. And so now we have a quadratic equation that we'll be able to solve. So we'll be solving for y, not x, but once we have a value for y, we can then go and solve for x. So I'm just going to rub out this on the right hand side here so we have a little bit of space. So I'm going to open up two sets of brackets. So we're looking for two terms that multiply to give 3y squared. So obviously that's going to be 3y and y. And then we need terms that multiply to give 9. And then when we sum the product of the inner and the product of the outer, we have to get minus 28y. So I can see that that's going to be 9 and 1. So the inner terms multiplied give me y. The outer terms multiplied give me 27y. I need those to sum to give minus 28. And so they're both going to have minuses. And that's the factorization of our quadratic. I'm going to let each bracket equal 0. So 3y minus 1 equals 0. And y minus 9 equals 0. This gives us 3y is equal to 1. Y is equal to 1 over 3. And then obviously y is equal to 9. Now these are two values for y, but remember this question wants us to solve for x. So we go back up to our original that y was going to be equal to 3 to the power of x for this sum. We're just going to write that down again. So y is equal to 3 to the power of x. Now remember, we found out that y is a third. So that means that 3 to the power of x is equal to 1 over 3. Now how could we solve this? Well, we could say 3 to the power of x is equal to, what's the rule here? 1 over 3 to the power of 1. We can say that that's 3 to the power of minus 1 using one of the rules of indices. And now we can see that we let the powers equal and x equals minus 1. So that's our first solution. I'm just going to rub out this so that we have space to write our second solution. So let me see. We have y is equal to 3 to the power of x and y is equal to 9. So 3 to the power of x is also equal to 9. So 3 to the power of x is equal to 9 we can express as 3 squared. And then as before, the base number is the same on each side, 3. So we let the powers equal and we get that x is equal to 2. And so our two solutions to this equation are x is equal to minus 1 and x is equal to 2. So we're going to use a similar strategy with this second sum. So we'll write it out first of all. We have 3 to the power of x minus 3 to the power of 1 minus x plus 2 equals 0. And before we decide on what to let y equal, we're just going to tidy this up so that we can do something with this negative x here. This is what makes this question a little trickier than the one we saw previously. So 3 to the power of x at the start is fine. And then I'm going to split up the 3 to the power of 1 minus x into 3 to the power of 1 multiplied by 3 to the power of minus x. And then I have my plus 2 is equal to 0. So that's going to be 3 to the power of x minus. So 3 to the power of 1 is just 3. And here in the second part, 3 to the power of minus x, we know that if we have a negative power, that we can make that power positive by putting the 3 on the bottom of the fraction. So 3 to the power of plus x. And then we have our plus 2 is equal to 0. Just look at a slightly different way we could have done this one. If we take the 3 to the power of 1 minus x, we know that there is a rule that says a to the power of 7 over a to the power of 2 is equal to a to the power of 7 minus 2. And so obviously we can work back the other direction. So if we have 3 to the power of 1 minus x, we can say that that's 3 to the power of 1 over 3 to the power of x. And that would have got there just a little quicker if we had wanted to do that method. So now we don't like this fraction in the question. So what we're going to do is we're going to multiply every term in the equation by 3 to the power of x to get rid of this 3 to the power of x from the denominator of the second fraction here. So 3 to the power of x times 3 to the power of x is going to be 3 to the power of x squared minus 3 over 3 to the power of x times 3 to the power of x is going to just be 3, and then 2 times 3 to the power of x is 2 by 3 to the power of x. And so we again have our quadratic. It's in the wrong order, so we're just going to rejig it. We have 3 to the power of x squared plus 2 on 3 to the x minus 3 equals 0. And now we can see it looks like a quadratic, and we're going to replace the 3 to the power of x with y. So let's go and do that. So y is equal to 3 to the power of x. So I'm going to replace this and this with a y. And so my new equation becomes y squared plus 2y minus 3 equals 0. I'm going to factorize this, and I get y and y, 3 and 1, a plus and a minus. So y is equal to minus 3 and y is equal to 1. Now remember, as before, these are the y values, but we need to find x values. So we're going to let each of these values of y equal 3 to the power of x. So we're going to let each of these values equal 3 to the power of x, but we'll see that not all solutions are valid. So we have y is equal to 3 to the power of x. We know that y is equal to minus 3. So 3 to the power of x is equal to minus 3. There's actually no solution to that. We cannot raise 3 to any power and get a negative number. A positive number to a power will not ever turn into a negative number. So let's go and let 3 to the power of x equal our other value for y, which is 1. And some people might spot straight away that the only possible solution here is 0. Remember that any number to the power of 0 gives us 1. We could write it like this, that 3 to the power of x is equal to 3 to the power of 0, and then obviously let the x equal the 0. But it is important to remember that anytime you have a number to a power and then the solution to that is 1, well then that power has to be the number 0.